Okay, I'm going to start now. I'm Francisco Quintero. I'm a lead firmware engineer. I'm currently working for Verizon Telematics. I decided not to put that I'm working for Verizon because Verizon is not actually endorsing this presentation or sponsoring. I'm just trying to contribute to the community with what MQTT is, but we are not using MQTT internally in Verizon. We are using our own protocol because the company I was working before, which is Network Fleet, was acquired by Verizon in 2012, and that company has been running for now is close to 15 years. So we ended up developing the protocol for our products from scratch. That's why I decided to talk about MQTT, because MQTT will avoid, if you end up using MQTT for your solutions, you will avoid having through all those problems that you encounter when developing protocols from scratch to do networking or to develop a solution for a business. So, well, as you know, the Internet of Things is the next frontier. We know that there will be lots of devices connected. Yesterday in the keynote, they were saying that you might have at home 20 IPs or more, of each device having an IP address at home. Now imagine all this is growing exponentially, so worldwide. In the end, we will end up having a frying pan talking to another frying pan, or to the stove to do smart things, whatever. It's crazy what is happening right now. And I brought this picture, which shows the evolution of the network or internet in this case, how in the very beginning was being used for military purposes, then now in the end, it has evolved into the wearable embedded market. And the number of devices we're expecting to have connected by 2020 is 50 billion. It's crazy. In a previous presentation today, someone was talking about IPv6, and that it's not still widely used IPv6. I mean, it has been available since 2002 or 2000 IPv6, but still we're facing a lot of problems because has been adopted massively, and we need IPv6 to be able to connect all these devices. And that guy also mentioned that if you plan on getting an IP now, you have to get one from Africa because all the others one are already gone. So of course there's a lot of opportunity in all these markets in the Internet of Things. That's why probably you are here. At the very end, I'm going to ask you, why are you here? Why are you interested in MQTT? If you're a maker hobbyist or if at work, you need to solve a problem related to wireless and networking in between devices. So the problem definition. The main thing here is that you have devices, small devices, connected everywhere, and they need to talk to each other somehow. So the classic way of doing things is that you will want to write something from scratch. Having a server, a central server, your devices will send messages over the air or in wire form if you have Ethernet available. And then you'll have to write that server code to get a list of all those devices that are getting connected, and then you're going to route those packets to each of those devices. Well, with MQTT, there's no need of coding all that because it's already implemented. It's a protocol that was designed in 1999. I will go into those details in a few minutes. So the key point is that there's no need of writing your own networking code to take care of connecting devices to make an Internet of Things solution, okay? Now, especially MQTT works very good on unreliable networks. What I mean by unreliable networks, any wireless network has to be considered unreliable because you might drop a connection. That's something that happens very common at work. As I told you, I've been doing this for 7 years, and that's the main problem. When customers go out of coverage, how are we going to store all the data so we can transfer it later? That's one of the most common problems you find in the wireless industry. So MQTT has a lot of features that were implemented since the very beginning to take care of all these problems. In particular, cellular, satellite, or any wireless technology in general will suffer from these problems. And now, mainly Internet of Things is mainly wireless, right? Because now no one wants to use wires, or all your kids or all the people that they were born in the new millennium, they don't want to know about wires, right? I still like to have an Ethernet cable available because I know it's faster. I like it, but no one likes it. No one likes it. So all your wearable devices will be wireless, and they will have some sort of either Bluetooth, Zigbee, Wi-Fi connectivity to your phone, and then it will send it to the cloud. But the key point is that there's a wireless factor. So we are living in a world where Internet of Things will have to deal with unreliable connections. Now, this is the agenda, the different topics we will cover. This is what I know about MQTT. This is what I've been using. If any of you knows more, then or please bring to my attention any feature that I'm missing. And at the very end, I will run a very small demo to show you how on Ubuntu, it's very easy for you to install one of the many MQTT brokers available, which is Mosquito. Chris Hallinan was mentioning that to me. That's precisely the one I chose for the demo. It's very well supported, runs well on very small devices or in full-fledged computers. So what is MQTT? It's a very lightweight protocol that uses the publish-subscribe pattern. That was all this was invented in 1999 by Andy Stanford Clark. Is he there or isn't he there? Because he was in the morning in a keynote. And excuse me?
He's still here. He's not in here.
He's not in here. Well, yeah, he knows. Yes. Why to attend an MQTT conference if he's the actual inventor of this? So he invented all this in 1999 while working for IBM. He's still working for IBM. But the main problem is that they needed to send data from sensors on oil pipelines in the desert through a satellite link. So imagine how was that in 1999? What kind of technology was there? I mean, satellite, this is still expensive now, but it's a lot better than it was back then. So that's when they decided to design a protocol from scratch to take care of their needs. So they ended up designing MQTT, which, by the way, now MQTT is getting a lot of attention because it solves precisely the problems of the Internet of Things. Key aspects: designed to handle high volumes of data in very low bandwidth environments. Low bandwidth. What I mean by that is that the amount of data that you use is expensive. Is a limited resource. Of course, all of you have data plans on your cell phones, and you know that when you exceed that data plan, it's costly. Now imagine what happens when you are doing that over satellite, or even in cellular, if your device is running on batteries. So you don't want, some products, some customers are expecting your devices to run on batteries for years. So you have to be very conscious of the amount of energy your device is using. So when it's time for your device to wake up and send a message, it has to send very limited payloads and be very efficient to guarantee that the payload is going to be delivered to your server, and then you can deploy it to your customers, or it can be visualized on a web page. So, of course, is designed to take a very small footprint of code. MQTT can run on, in my case, I've been able to make it run on an STM32 F4 microprocessor, which only has 128 kilobytes of flash. So I'm running a USB stack on that one and MQTT code. So you can make it run in very tiny devices that use very small energy. And runs on TCP, so that's something that you have to take for granted. The protocol assumes the TCP IP stack is available. Currently there's no flavor of UDP for MQTT, but that's not really an issue. The payloads are actually very, very small, so that's not a problem. Avoids polling. Well, you know, polling, like in the server client model, when you do polling, the server has to constantly poll the client to see if there's new data available, or if there's an event going on. In MQTT, the polling problem is not there. It's actually pushing data. Even though it's event-oriented. And the recovery from a loss of connection is part of the protocol, and the store and forward feature, which I mentioned. If you're in a particular situation where your device has collected data from sensors or any kind of data in particular, but there's currently no link available to your server, the protocol takes care of keeping all that information in place. Of course, you have to store it in flash or in some persistent data, but the protocol has provisions to start sending that data as soon as the link is up again. You don't have to explicitly take care of those nuances. The protocol does the store and forward and the recovery stage properly. This is a picture I found on the HibMQ site. That's a German company that they are actually providing a commercial grade MQTT solution. So the publish subscribe pattern works the following way. Your devices are going to publish data to a broker. I will talk about client or broker in the next slide. Broker is an essential part of MQTT. Broker is the part that will run on the server. The broker is responsible to get messages from all clients, all the data that clients are publishing, and the broker will decide who or what set of clients must receive notification of that event, the event that happened. Here we have sensor is reporting temperature, and the broker will send that data to the subscribers. So when a client subscribes to a broker, it will specify to which topic is interested in getting notifications from. So a broker might have any number of clients connected, but only some clients are interested in certain events. So only those clients that publish that data, the data will be delivered to the other clients that are subscribed to a particular topic. Oh, and by the way, topic is another essential part of MQTT. Topics is how a client specifies what it is interested in. Okay, topic is, in this case, are ASCII strings. So whenever there's a client doing a subscription, They have to specify what topic they're interested. There are wildcards, of course, so, but that's not a best practice. If you want to subscribe to all topics, you will get a lot of traffic, and that will probably kill your bandwidth and your battery. So one of the advantages of publish subscribe is that it completely decouples one client from the other. That's a problem that we've seen very commonly when you're developing your protocol from scratch. In the end, you end up having you write your protocol assuming that information from one client is known by the other client, and MQTT solves the problem. There's decoupling in the protocol. As I told you, clients are always connected to a broker, and of course, a client is a publisher, but is also a subscriber. So they have this duality, and MQTT uses topics to determine which message is routed to each client. And the topic, as I mentioned, is an ASCII string that can be delimited by forward slashes. I will show you that later. Now, a client can be a microcontroller to a full-fledged server. I don't know how many of you are familiar with the ESP8266. You're familiar? Someone else? So MQTT, you can run MQTT client on an ESP8266. So the ESP8266 is a chip made by Espressif. It's a Chinese company that just became available, I think, 2 years ago, and is being used widely in the maker community. It's a Wi-Fi chip that you can get for less than $6, and you can program it in C directly, internally. The TCP stack is already included. So only $6, a cross-compiler, you can download code there and start making your Internet of Things stuff. I mean, it's incredible. I mean, a pound of ham is more expensive than a powerful microcontroller now. As I told you, the client code in plain C from microcontroller, of course, without the TCP/IP stack, but just the code to implement client code of MQTT, only needs 30K bytes of code. So that's I mean, right now, any microcontroller can handle that. If not, then there's no point of keeping it. And in Java, well, Java requires, of course, more, but I put it there for a comparison, 100K bytes of code. Now, and also, of course, there's a lot of support for MQTT in different languages, so that's not an issue. Right now, you can choose any language, and there will be an MQTT broker, or most importantly, the client side, because that's what you are interested in. Because the broker, you can, we're assuming you have a machine that's running a full-fledged server that can run anything, but on your client side, you have many options to choose from. Now, the broker, as I told you, is the receiver of all messages. It handles authentication, authorization of clients. There's a password feature on MQTT that, in case you are interested in having some sort of authentication, that can be used as well. And highly scalable. For example, Andy, I think Andy he's running a home automation at home, and he was able to connect Twitter to an MQTT broker. So on Twitter, he was getting notifications of events happening at home. And I think in the morning he mentioned that he has this rat trap, and when a rat was getting trapped, it was notifying the company, for the pest control company. So It's very easy to interface to an MQTT broker, to Facebook, Twitter, any kind of those solutions. Now, we'll get into some details of the protocol. Always a connection is started by a client. So we are assuming that. And this is important because if you are behind a firewall, then the firewall will use NAT to do the IP transformation from a private address into a public one. But since the client is the one initiating the connection, that's not an issue, right? Because your server will get the public IP, and that's what matters. The firewall, router, whatever, will take care of translating from public to private, and you'll get your messages too. You don't have to worry about that one. That works because the client is always the initiator of the connection. So it will send a connect packet, and until the broker sends back a connection acknowledge, then an MQTT connection can be established. So in these bullets, probably there are too many words there, but these are, think of this connect packet as a structure, as a C structure with each member is one of those fields, right? The client ID is a unique ID per broker. It has 16-bit, so that's enough for 64K of IDs of customers per broker. There are the clean session. That's a flag that you can specify if you want the session to be persistent or not. Persistent means that certain attributes of the session are preserved by the broker and the client when the connection breaks for some reason. So when a connection gets reestablished, those pieces of data that were already in place don't need to be resent or relearned. And there's also quality of service feature. There are 3 levels of quality of service. Since this is a wireless, mainly a wireless protocol, with the quality of service will help you control the warranties of your data being delivered to the server. Of course, you can control if you're not interested in wasting too much bandwidth, assuming you can lose some data. Think of video, right? Video, if you're streaming, you don't care if you lose a few frames because the next one probably will look very similar. But in some other situations, for example, if you're sending GPS fixes from a customer, you must be absolutely sure that your packets are reaching the server. So you can control that using the quality of service. The username and password is that one is encoded in plain text. For that particular case, your application has to encrypt it explicitly, and then you can just embed your encrypted string into that part. So MQTT is not taking care of doing the encryption. Of course, you can encrypt also your data, and MQTT is just the transport from the client to a customer. Will message, this is important. That's, as I told you, when a connection is broken ungracefully means that the client did not explicitly send a disconnect message to the server. If the will feature is enabled, then the broker will take care of taking a set of actions with all the other clients that are subscribed to a specific topic. So that's when the will message comes into place. And the keep alive, of course, is a feature that Andy in the very beginning said that TCP IP, those of you that have used TCP IP, you know that sometimes a socket, when it breaks, it will return an error, but sometimes the socket, it will not return an error, but the connection is broken. And you keep writing to that socket and everything looks fine. So that's why a keep alive at the MQTT level is required to keep track of when the connection is up or not, or if it has been lost. Now the publish, subscribe, and unsubscribe pattern. This is used to reinforce what we've discussed before, that a client will publish data and then the broker will route those packets accordingly to all the subscribers. Now the publish packet, which is different than the connect packet, okay? This is what we discussed, connect packet, that's only sent once. And then publish packet, that packet is sent whenever, of course, the client has something to publish. So that's when the payload comes into place. MQTT is data agnostic, so you can transfer anything you want. I think the limit is up to 260 megabytes of payload, so that must be enough for you. If not, you can send 2 or 3 messages. And in the publish packet, the quality of service, as we mentioned before, now they retain flag the topic name, which is a string delimited by forward slashes in ASCII, and that's the topic or set of topics your client is interested in. The retain flag, that as it's mentioned there before, is used to control when a client subscribes to a service, but there's no new data, or if the publisher is gone because the connection is broken. Anyone subscribing to that particular topic will get a copy of the last known good value. There are many scenarios where that's important. For example, we have cases of customers that are interested in getting the odometer of their vehicles, and if the vehicle is offline, they'll get the last known odometer that was reported. This sounds like trivial, but as I told you, we had to develop all this in our protocol, but MQTT is already taking care of this, so you don't have to worry about that one. The packet identifier is a number that you can use. It can be a sequence number or any number that you want to use. If you want to take advantage of at your application, you have to take care of using the packet ID chosen. And the DUP flag, that's a duplicate flag. As you know, in wireless networks, it's common to have duplicate packets because it's an unreliable. So someone has to deal with duplication. So in this case, MQTT has that feature as well, but is dependent on the quality of service. So depending on the DUP flag, if you set it, it only matters for quality of service greater than 0. When we get to quality of service details, we'll understand what 0, 1, and 2 mean. And as it says there, the retries are being handled by the MQTT protocol itself. It's not something that you have to handle. Now, subscribe. This is the other end. When a client, I keep saying customer, but when a client subscribes to a particular topic, it will send this kind of packet. So the packet ID is also listed, but what most important is the list of subscriptions. The list of subscriptions is the set of topics he's interested in. That we discussed before, those are just ASCII strings. How are we doing? Okay, 30 minutes. Yeah.
And the publish packet, why do you need the publish packet? The previous one?
Publish?
Yeah, why do you need the duplicate flag if you're running TCP/IP?
If
you always run on TCP/IP, which is a guaranteed protocol. So why do you need duplicate flag? When would something like this happen?
My understanding is that although, I mean, TCP will take care of doing the guaranteeing the liberty at the transport layer, but sometimes in the application layer, the same packet might get sent twice by your logic. So I don't have exactly a scenario on how to explain it, but some sort of, as the keep alive, right? Keep alive, in TCP/IP, there's an explicit, or there's an implicit keep alive packet in place that you can control using the setsock options. So the TCP/IP stack determines when a connection is broken. But if you are not using that feature, that's why Andy decided that MQTT needed to handle that at the upper layers. I can talk to you at the very end to yeah. Yeah.
I didn't understand the situation. It's like who's setting the packet identifier? Whether it's like per packet.
Who's setting
per flow or
the packet ID? Yes, is yours. That's your application because.
And this sets for the whole traffic flow between the two devices, the publisher and the subscriber.
Yes, yes. This is a number that you can set. You might decide to use it or not. But as it's explicitly, as it's stated there, the packet ID is only relevant for quality of service 1 and 2 because that will help MQTT to correlate when to do retries on its internal stack depending on the quality of service that it needs.
So when I start the MQTT, whatever socket like thing to publish something, I send this as a one parameter every time I do the socket, or just one time, and then for every publish it will just pick up this time. I'm talking about the programming action, the actual usage of TCP/IP.
I think in my use case, I use initialize it and then I start sending data. Yes, yes. And in my case, I'm only bumping or changing the ID when the data that I'm publishing is of different nature. It might be the same device, but sending, let's say, I have one for humidity, one for temperature, but all the temperature ones I'm just. Since I only care about the payload. That's where I'm putting the actual information. I'm letting MQTT handle all the other details. But of course, you can fine tune it to your application depending on the situation.
Does the broker keep track of all the packet identifiers for different flows?
Yes, it's needed. It's needed because it's important for the broker because the quality of service set by a publisher, it can be downgraded if another subscriber specifies not the same quality of service that the publisher is using. So the broker might decide, okay, I was requested to honor quality of service, let's say 2, which is the highest one, in between the publisher and the broker. But when a subscriber connects and this subscriber knows that is running, let's say, on satellite, it might decide to use quality of service 0 because it wants to keep the bandwidth usage to a minimum. So in this case, the broker knows that the subscriber wants to use 0, and that's why the broker knows about has to keep track of these details, the IDs. Yep, it's a very good question. Subscribe packet, yeah, we discussed this already. The list of subscriptions as a strings, and the unsubscribe packet. That's useful to, same was more or less we mentioned that before, that a client, if it sends explicitly an unsubscribed packet, then the connection is considered a graceful disconnection. If there's no unsubscribed packet, then all the other details we discussed about what happens when, like the last wheel, the retain flag, those are used when a client just dies, which by the way, that's, I would say, clients having ungraceful disconnects is, you'll get it like 80% of the time when you were running on wireless. So you have to deal with this, right? Once in the field, in wireless, it's like all the assumptions you were making are wrong. Connection will keep breaking, you have to store all data, keep the customer happy, of course, if there's some business involved. Now topics, they are UTF-8, they are case sensitive, so you know what this is about. Wildcards, there's a 2 level of wildcards on the topics. The plus sign is a single level wildcard, and the pound sign is multiple level. So I just put some examples of what when plus or pound can be used. And a pound can be only used at the end of the topic string. So now quality of service, 3 levels. So 0 at most once, 1 at least once, and 2 exactly once. So 0, in 0 there are no acts from the receiver. Think of it more or less as, let's say UDP. If you have used UDP, you know UDP is like a mail service. You send a letter, it might not reach the other end, but if you make a phone call, you know there's a switch established, so there's communication in there. So if you choose 0, packets might get lost because there's no acknowledge from the receiver. So you're assuming that, okay, probably this didn't make it, just as I was mentioning before. If you use video, you can support lossy transmission if your solution can handle it. And the number 1, the message is guaranteed to be delivered once, but chances are you might end up getting duplicates. So you're now potentially using more bandwidth than with the quality of service 0, but you have that like middle level of QoS. And 2 exactly once, that's the highest level. Your packet will be delivered, but that's the one is slowest, and it's the one that potentially will use more bandwidth, more packets will be required between the client and the broker and the publisher to make sure that the packet was delivered only once. And the quality of service, as we saw before, in the structures or in the members of the structures, that's where you set the quality of service. And the broker will honor the QoS set by the client. And it can be downgraded if a client specifies not the exact same level upwards quality of service that you specify. Now, persistent session. So the persistent session, that's and queue management. As we were saying, the main point here is that you can control if the data client is sending to a broker, and the broker, if you specify that you want persistence, then the broker will keep that data available. So when a subscriber gets there, it can start retrieving those packets. But this is something that the nice feature is that the client decides if if persistent data is important. If you are posting temperature, probably you are not interested in knowing what the temperature was 1 hour ago. You just want to know the last known. Or one example where persistent is important, let's think of a vehicle and you are posting the key states, right? The car is off, now the key is on, and you want to keep track of all those events. That's when queuing is important, because you are going to send all these key states and the publisher will get them in order. They are being queued for you. And with the quality of service, there's some interesting combinations on what you can do with how the broker and client handle the persistence. So as it says, with QoS 1 or 2, the messages will be stored in the current session. All messages will be stored if you're using QoS 1 or 2, but the ones that are not confirmed by the client. And when clients, they missed some messages when they were offline, when they were not connected, out of coverage. And the quality of service 2, the ones that are not yet confirmed by a client. So the confirmation means that there was already a transaction in between them. Yeah.
So you mentioned the message order is preserved. Is that preserved across only one publisher or across multiple publishers?
It's so the broker. Okay, it's not exactly as a queue in the sense that the one consuming the message will get it and the others are not going to get it. So.
One of it is like, for example, I sent 1 and 2 to you, right? And then you will give it to the client as the subscriber in 1 and 2 order. But they say he's the other publisher, he says A and B. After me, will the client get 1 to AB or AB 1 to?
They will get delivered or queued in the exact same order. So if someone sends 1 and 2, and on the other end you have 2 subscribers, but one subscriber came into play before than the other one, it will get 1 and 2. Then the other one gets there, it will get 1 and 2 as well, if it's specifying the same with the same quality of service and persistent flags. So each subscriber will get like copies of these the events that were published, because otherwise, if a consumer, if a subscriber gets there and gets 1 and 2, and then the other one subscribes, but the data was dequeued and not preserved for other subscribers, then they won't get it. So it's like each subscriber gets its own like a message queue. So it's not a message queue for all of them, but per subscriber. And that way there's no loss of data. Retained messages is the last good known value that we discussed before. This is just to emphasize that part. So, and retained messages, something important is that you can set the retained per packet that you are publishing. It's not something that once you set it is preserved along the session. You might decide that you want to retain only certain packets you are publishing, but not the others. So that's what that means, that a retained message is the last message with the retained flag set to true. And to delete the retained message, this is one of the ways of doing it, that zero payload with the flag set to 0 can be sent. That's one way of deleting it. So any other subscriber won't get that retained because there will be no more data to be delivered. Yep.
So, is that the way to keep the messages in the broker for a specified time, or is there a time to live associated with these messages? Because what if you publish a message, send a message to a broker, but there's nobody to subscribe, nobody listening on those messages?
That's a good question. In another slide, the max time it will be kept, I think, is 18 days or 18 months. But there's a limit on for how much time is that message going to be kept by a broker. So in this case, it's the broker itself, the MQTT code. If you need more time, then probably you have to handle that in the application. But MQTT per se will handle up to 18. I don't remember if it's days or months, but we'll get into that. Let me get. 18 hours. No, that's the keep alive. Yeah, I'm confusing the two concepts. Yeah, but there's no. As far as I know, there's no limit. Yeah, it's only the keep alive to handle the graceful or ungraceful connection. So on retain, there's no.
So the message could stay in the broker forever until it's consumed.
Yep. Yep. Do you have a particular scenario where, or in one of your projects you were working on where that's something?
I'm just thinking.
Okay.
You'll end up using a lot of resources if you hang on to messages.
Yes. Well, in this case, since the broker requires a lot more code than the client, that one's running on a big machine, and we're taking for granted that one can run on consuming more power, has access to bigger disks. It's the client that can be really tiny, very energy efficient, and assuming that the broker is handling all these details in the middle. That's why the broker is an integral component of MQTT, and there's no way to run the MQTT protocol without having the broker in the middle.
I can think of a use case where I want to send a message to some client, some other device somewhere, but I want it to be valid for a certain amount of time. If they don't log in and pick up the message, I want it to expire, for example.
Yes. Yep. And that's why you can delete it, right? But in this case, the client is responsible of deleting a retained message if it was not consumed. So you might decide to clear it. I don't know. Your client is publishing data, and the client doesn't know when some subscribers are already there getting data. Right? But let's say that you might decide to always clear a retained message every 24 hours at 12 a.m., right? So if any subscribes after that period of time, they won't get it. They have to be within those boundaries. Last will and testament. So the last will and testament is what the broker is going to do when there's an ungraceful connection and there are subscribers connecting to a broker. This is very straightforward, that part, and but very is used heavily because, as I told you, the connections usually break when you're running wireless. Wow, 10 minutes left. Keep alive. Well, the max keep alive is 18 hours. I will speed a little bit up because we have to handle questions, and I'm interested in knowing why are you interested in MQTT? What are you currently doing? So the keep alive, we already discussed it, and the client takeover is that is what I mentioned before, that using the TCP/IP stack, there are cases where either the client or the broker will think that the connection is still up, but it is actually not. So let's assume that we have a broker. It gets a connection from a client, but the connection broke. But the broker thinks that the connection is still open, right? So the client might decide to reconnect. So what the broker is going to do, based on the packets, the IDs, it will detect that the same client is connecting again. So it will just create a new connection for it, and it will kill the other one, or decide to release the resources related to that one. Some comparison between MQTT and HTTP. MQTT is around 5 times less bytes than HTTP, but HTTP, of course, was designed to use wires, right? It was not that the wireless revolution came after with the I think it's primarily the iPhone. That's when everyone started massively usage of smartphones, and that industry ended up driving prices down for GPS, for modems, for everything. And then everyone started designing IoT stuff. MQTT is using a lot of verticals, a lot of different markets and solutions. And well-known companies, for example, Facebook. Facebook is using MQTT for their messenger. Why? Because when they came up with the Facebook Messenger feature, they found that there were a lot of latency, and then they found out about MQTT. They decided to start using it, and they were getting close to real-time performance, rather than seconds. So, and this happened around 3 years ago. But keep in mind that MQTT has been there since 1999, right? It's not that now it's becoming like that golden thing. Now, as you're aware of, as you know here in the conference, there's a IoT. There are now lots of frameworks for IoT. But the nice thing about MQTT is that it has been there for a while and has stood the test of time. Amazon has an IoT platform, the Amazon Wireless Web Services, and they are using MQTT for their IoT services. So let's suppose you want to design a product and you want to use Amazon for their service. Well, you have to implement MQTT on the client side, and you can start connecting to it. So then you don't have to maintain your own server, your own cloud. You can use Amazon, and you just take care of designing the actual hardware you're going to sell to your customers, and you can save a lot. And you know, Amazon has a lot of power on reliability, and you can set up your virtual server. And if you want to start, you don't want to start, you want to stop paying 1 month, you just stop and period, right? It's that easy. Now, the Eclipse Paho project, that's the one I've been using. There's an embedded MQTT client. That's the name of the person that developed all that source code, Ian Craggs. Is in ANSI C, so in my case, I'm compiling it with the GCC compiler for the STM32 Cortex M0, M2, 0. I've tried 0, 3, and 4. Compiled fine with the GCC compiler. Didn't have too much trouble with types because it's written in ANSI. It was very easy to start using it. And of course, there's also a C++ component for the embedded part, but if your machine is very small, try not to use C++. Well, if you want, yes, you can use it, right? Now, current libraries under this embedded component, there's an MQTT packet, which is the lowest level component you need to start creating packets, MQTT packets for the client side. There's an MQTT client component, which is a little bit heavier, and the MQTT client C, that specifically talks about FreeRTOS. But all these two, the two components at the bottom, all of them rely on MQTT packet. I'm going to show you a snippet of code that uses MQTT packet to create a packet, to create on the client side. So I'm going to use the mouse here, yes. So from here to the top, you only need all those lines to put your payload into a packet. And then, you're not seeing the mouse, right? The mouse is not there. Oh, yes. And now from that comment, the last 3 lines, that's where you are free to use the networking underlying structure you want. You might have a modem and you want to use AT commands to send data back and forth, or you might be running your broker and you are using Bluetooth for that connection. So the important thing here is that MQTT packet is what allows you to create the actual payload you're going to transfer, right? Then on the other end, the broker gets the package and passes it to these APIs to deserialize the packet. But this is very important because, as you see, there's no dependency on the underlying networking infrastructure. So that's why this one you can embed in the small machines very easily, because it's not assuming there's the full TCP/IP stack available or not. So, quick demo. How are we doing on time? Okay, 2 more minutes. I will show you. Try to do this quickly. Okay, so, oops. Sorry, that's very small. Or can you read it? Well, the bottom half, I'm going to create a subscriber that will subscribe to the ELC topic, and then we will publish something to the ELC topic, and the subscriber will get it. These are mosquito clients. You can, if you're running Ubuntu, is using the apt get mosquito and mosquito sub and mosquito pub. You can download it and start playing with it. So there you have says Conac, Sovac. That one will show up around every like 5 or 10 seconds. So that's the actual subscriber. He's not getting any data because no one has posted anything. Now we are going to run a publisher into somewhere else.
Broker's already running.
Yep. Oh yeah. Important feature. In this case, the broker is running as a daemon. Anytime I start the machine, the broker is in the background. That's why it's a daemon, right? We don't see it. Stuff MQTT. So let's echo MQTT presentation. Let's do publish txt, right? So there we just put the payload MQTT presentation into that file. Let's see. Publish.txt. That's the actual binary payload of the file we just created. Now we're going to post it. I'll put this one here because we have more space. There you go. You got one at the top, which is the subscriber, got the actual string, 18 bytes. And those are the exact 18 bytes that we have here at the bottom. So it's a very quick demo. Of course, it's very limited, but you can start playing with it from any Linux of your distro of your choice. Yes?
So question, I mean, how common or uncommon would you see using this as an internal messaging bus that's used for kind of single publisher, multi-subscriber embedded systems?
For embedded, how you say how? I would say that if you try it, I know MQTT is getting a lot of attention, or actually has a lot of attention because it's already there. It's easy to implement on small devices. It doesn't require too much infrastructure as some other IoT frameworks. So if your client devices are very constrained in resources, try MQTT. It's very lightweight, very easy to set up and to monitor and to interface with other
Do you know of applications that use it as an internal message bus for a single embedded system, as opposed to like kernel multicast, that type of messaging?
I don't know, besides Facebook, you mean on the embedded side?
Not so much. But it's usually for a distributed network, right? But running it all on a monolithic embedded system as a messaging queue that has last will testament, that has timeouts, that has people ads, right? These are things we typically end up solving in the application space, right? You know, we use kind of Unix streams or we build our
Okay, so you say, I'm sure. I know in the home automation market, there are many companies using it for the actual devices that you might have 3 devices in a room, all of them checking humidity, temperature, I don't know, UV, right? Ultraviolet, whatever, or monitoring CO2, but these are small devices, all embedded, and they send all these packets to the brokers, an actual hub you have on the wall, and from there you can send it to your backend, which everything's nice, a lot of power, disks, big server. Many companies in the home automation, I think the home automation market is where most of this is being used. Yes.
So a subscriber can basically subscribe to a topic that does not exist, and that would not be an error condition. Is that correct?
Yes. Yeah. Because probably the client is, well, of course, it's not still ready, but that's not an error. That's not an error. That's considered.
He doesn't have to be a publisher to hear a published message with a list of topics first before we can.
Exactly. Yeah. Can be handled.
Is there a high availability feature for the broker? If the broker dies,
Well, what would happen if the broker is not running, when the client tries to publish or to connect, it will get an error. So in that case, your application has to handle okay, let's try to connect again because the broker is not there.
you have a backup
Yes, you can have something that a solution is very common. Your client, of course, you have to know the IP of your broker, right? Because that's where you are sending the packets. So if you're trying to reach your broker and you don't get a response, as part of your solution, you might decide to have another broker running on a different machine, and then your client falls back to try to use this other IP, and then that one is supposed to succeed. So, but that's more like the actual business fail-soft strategy you want to take. But yes, you can have as many brokers as you want, and from them connecting them to large databases and the actual business logic that your customers are going to see. So we are ready at, well, there's a break, right? So if you have more questions, we have time, because there's no other conference following this one. Thank you, and thanks for coming here.